Hello all, welcome to the show. I'm Gus Gagliardi and this is Fire Code Tech. On Fire Code Tech, we interview fire protection professionals from all different careers and backgrounds in order to provide insight and a resource for those in the field. My goal is to help you become a more informed fire protection professional. Fire Code Tech has interviews with engineers and researchers, fire marshals, and insurance professionals, and highlights topics like codes and standards, engineering systems, professional development, and trending topics in the industry. So if you're someone who wants to know more about fire protection or the fascinating stories of those who are in the field, you're in the right place. Hello all, welcome to the Clips episode of 2020. I wanted to highlight some of my favorite episodes from the first 8 months of Fire Code Tech and bring some more content as a bonus feature in addition to the 2 episodes that I'm going to release in the month of January. I'm going to have a couple different segments in this Clips post, and if you want to skip around, I'm going to have all the information in the show notes. I'm extremely grateful for all the people who have supported Fire Code Tech in the first 8 months, and I wanted to just say thank you. My goal for 2021 is to keep putting out content at the regular intervals I have been, and also to add some new features to the podcast. In addition to all the other locations that I upload the episodes of Fire Code Tech, we are now on YouTube. So if you're more interested in short form content, then you should check out our YouTube page. You can find the link on our website at firecodetech.com and all of our location and publication information there. If you'd like to help out the show, be sure to subscribe wherever you listen to your podcasts. Also, follow us on social media so you can find all the great information we post about fire and life safety. Let's get started with the show. Our first category of clips is called Fascinating Stories and Careers. On Fire Code Tech, we talk to people who have incredible careers and backgrounds. During these interviews, we usually get some really interesting nuggets about people's careers and stories from their travel through fire and life safety. Our first clip is from Bill Gustin, somebody who has no shortage of incredible stories from his time in the fire service. In this clip, he speaks about some of the harrowing incidents that he had early on in his career. If you are interested in listening to the entire episode, check out the show notes and I will annotate which episodes these clips come from.
I experienced some things at a very young age that have just stuck with me my whole life. In September of 1973, we were at a meeting, paid on calls, call them volunteers. And we had a call for a fire at a drugstore that was adjacent with a party wall to a grocery store. We went in there. It was a little bit of light, wispy gray smoke. As we advanced an 1.5-inch line, thinking that we had a fire in the storage area, about 200 feet deep into the building, we saw a bluish orange flame blow out of one of the air registers, HVAC registers. We did not know that this building had a bowstring truss roof, had a tin ceiling, and the fire was roaring in that truss loft, and we didn't know it. And thank God we were not successful in pulling that ceiling, because had we been successful, it would have been like opening up the damper of a wood-burning stove. So we got out of there, and within minutes, the entire roof collapsed. It would have killed about 20 of us at a very early age. Bowstring Truss.
I remember being awestruck when I would hear Bill Gustin talk about some of these stories when we were doing the interview. Some of the impetus for the guests in the podcast for Fire Code Tech are subjects that I didn't know very much about. This next clip comes from a guest who has a career in a field that I really didn't have much knowledge in before I started doing research for the episode. Richard Meier gives an incredible story of Richard talks about one of his explosions investigation, and it's a really fascinating story about what the cause was for this exact explosion investigation.
Well, actually, I've had 2 cases, and I can talk about them because they're both closed. Generally, I don't discuss cases that are open and in litigation, but the first case was in Detroit, Michigan. It was a gas leak, and this was a catastrophic explosion. The homeowner was entering through the back door, turned the light switch on. Basically, the house turned into smithereens. There was a debris field extending about 100 yards or more in every direction. The house next door literally had shrapnel that went through the exterior walls, through interior walls. And this was a house that was built in the 20s, so it had lath and plaster. I mean, this is stuff that'll normally stop bullets sometimes. But they had shrapnel that had gone through multiple walls. Unfortunately, nobody got hurt in that one. The homeowner at the house had exploded, unfortunately, died from his injuries. But in this case, we had a home that was initially hooked to natural gas and then was later converted to propane because the owner of the property owned a propane company. So he could get propane fairly cheap. But the gas line still ran into the house. So then the question became, where was the leak? Not so much as, what the ignition source was, more or less likely that it was the turning on the light switch is what did it. But it came down to doing an evaluation of both systems, and we had found out that the natural gas coming from the gas company, they had a number of leaks in a gas main across the street. And this is about 60, 70 feet away. The gas main was an old steel main that was almost 80 years old. So it had a lot of time to collect corrosion. Had a history of being repaired every 10 years or so. And on the couple of days before the explosion, there were some heavy rains. And what that does is it actually seals the ground. Normally, the gas was basically coming out of the pipes and going through the sandy soil straight up, and then you could tell there was a line of dead grass that followed the gas main. But on the couple of days before the explosion, there were some couple of days of heavy rain, and what that does is it saturates the top of the soil with water, making it kind of impervious to the gas flow. So the gas decided to personifying the gas, which I shouldn't do. But the gas then went laterally under the roadway, under the front lawn, and leaked in through the old basement walls that were a pretty porous block. By comparison, we found no issues with the piping for the propane. That is only a couple of years old. It was plastic. It was all solid. No issues found. So we determined that it was a gas leak from the gas main is what led to the explosion.
It was really interesting talking with Richard because I could tell from his experience with being a part of depositions and trial that he had almost no effort in speaking about these cases and about fire phenomenon. This next clip is from Andy Lynch. He has an incredible career as a fire protection engineer working in predominantly listing and testing. This story is about when Andy was involved with getting a detection system listed and incorporated into NFPA 72.
The big projects I worked on there were actually for the Navy, the Naval Research Labs. I think to this day, Hughes still has the contract with them, and they have a ship down in Alabama that we did a lot of fire testing on, which was a great opportunity. I was there and I was working on, now you're talking about 15 years ago, we were working on the detection suppression systems for the next generation of destroyer and carrier. And we were looking at video image detection. We were looking at UV, IR. We were actually looking at acoustic detection. So we had microphones in the compartments, and we could hear if there was a pipe rupture or some event going on. And then what happened was one of the startup companies that was doing video detection at the time actually hired me away from Hughes. And I worked for a company called X. I was actually the third person as a partner in that company. And we developed video image detection from what it would do was take normal CCTV cameras and feed them through a server and process the pixels to look for fire and smoke. We ended up building a fire lab, doing a lot of comparative testing with other detection, air aspiration, spot type, heat type, and looked at how video detection would perform. We migrated the analytics from the server actually on board the camera. So you had a self-contained detection device that had dry contacts that could feed into a fire alarm panel. And then we actually got that technology FM and UL listed, and there was no listings at the time. So we had to actually work through the process with FM and UL to create a new standard for video image detection and then test to it so we could get the UL and FM mark. And then we also got it into NFPA code, NFPA 72, adopted video image detection, as well as, we were finding customers and doing beta test sites and rolling out the product. We built it up to a point where Fike, which is a fire protection manufacturer, bought the company. I stayed on board with Fike for about 3 years, and that's when I left and started the Fire Solutions Group, which is where I am now, and I do mostly fire testing.
Andy is incredibly intelligent and was a pleasure to speak to. And let's face it, that Boston accent didn't hurt for the audio content. This next segment is called The Process of Being a Professional, and basically throughout the process of recording the episodes of Fire Code Tech, wanted to learn more about certain professions and wanted to provide a resource for some of these different careers and backgrounds. And so really, I just wanted to highlight the individuals and show people what incredible work that fire and life safety professionals are involved with. This next clip is from Chris Campbell, who is a professional engineer who works in construction in the DC metro area. He gives a breakdown of performance-based design and some of the options that you can use when you are trying to integrate performance-based design instead of prescriptive design.
One important distinction, I think, is that performance-based design can be used for all of the building design, but it can also just be used for a certain portion. So one example of that might be, let's say that you're well into a building design and you realize that there is a dead-end corridor issue. For example, you might just consider doing some sort of performance-based design to just mitigate that specific issue, but the rest of the building could comply with the prescriptive egress requirements. So certainly if it's going to be, your entire egress system is performance-based, I think that's got to be a pretty early determination. But there is an opportunity later on for perhaps smaller portions of the design to be performance-based. Regardless of at what stage that decision is made, it is really crucial to get the AHA on board. I've had the opportunity to work with some really knowledgeable authorities having jurisdiction. A few that come to mind are the Smithsonian Institution.
Wow.
They have their own fire protection, in-house fire protection group there that acts as the AHA, and they're generally very open to using performance-based design techniques. But at any rate, you obviously have to get the AHA to buy off on the approach that you're using, and if you're doing something like egress or fire modeling, they have to agree to the assumptions that you're using in those modeling approaches, ideally very early on. I think another good example of an opportunity to use performance-based design is when you're doing work in existing buildings. So I'll give an example. A few years ago, I was working on a project at the Kennedy Center in Washington, D.C., which is a very notable performing arts center in the district. And, they have some very notable and large-scale performances there. I think every president for recent memory has visited there for one show or another. But at one point in time, the garage that sits beneath the Kennedy Center Performing Arts Center, the garage had some exits that were discharging onto a sidewalk that was directly next to a freeway that goes through DC there, and they decided that they no longer wanted to use those exits just because of the danger that is associated with a sidewalk right next to a freeway. So we had an existing building that had a building permit, was occupied, and they wanted to stop using two exits. So adding additional exits elsewhere in the building would have been very disruptive and costly. So that's an example where we had an existing condition that they wanted to modify, and we used fire and egress modeling to show that even with the no longer using two of these exits, that the building could still be evacuated safely.
What an interesting story about how to use performance-based design as a tool to help you problem solve as a fire and life safety professional. Mike Snyder is a consummate professional when it comes to chemical safety and hazardous materials. Check out this clip where he gives an introduction to hazardous materials.
Sure. So, obviously, and I'll start with, I'll call it the academic side, and then we'll step back and I think talk about how you can frame this, that it's applicable really to anybody who is going to be touching hazardous materials in our work process. So, most programs in chemical engineering and chemistry are looking at the normal routes of basically how you take chemistry or chemicals and move them from kind of condition 1 to condition 2. Very seldom, and even today in the academic environment, is there a lot of discussion about unanticipated consequences, contamination, or undesired reactions. And that probably is, from a personal mission standpoint, getting that more robustly into our academic curriculum is still something that we need to do a greater deal of work on, right? And if you think about our practice in fire safety, loss control, and process safety, most of what we're really trying to do is, can you identify the potential unanticipated outcomes, and do you have proper levels of protection to deal with that? So, oftentimes, as we talked about, right, chemistry can be daunting. And so the things that, as I reflected upon this in preparation for our discussion here, that I have found to be very effective in dealing with clients and dealing with regulators and dealing with community members is, we have to take complex topics and frame them very straightforward and as simple as we can. And that doesn't mean gloss over important facts, but you need to be able to distill down, what is the exposure, what is the risk, and how are we going to control that? And I always kind of joked, right, if I could explain it to my mother and she could understand it, then I probably got it to the point that it was appropriate, that I've distilled it down to its most simple element. Because oftentimes we love to talk in acronyms, we love to talk in technical detail, and there's a forum for that, right, with colleagues and when people are doing technical review. But many times when you're dealing with a client or you're dealing with an owner or an authority having jurisdiction, without, again, trying to say, well, you can't understand this, but simplify the problem, and all of a sudden people get on your same page. And then I think you also have to think about the work process, and that is, you're doing some type of work here with this hazardous chemical or with the code compliance there. How does it fit into the broader picture? And the way that I do that is, and as simple as this sounds, it is the root of many problems in chemistry. It starts with, what is the problem we're trying to solve? And again, it's a very simple question, but I ask it 3 or 4 times a week when we get into places where, the client doesn't understand it, or the authority having jurisdiction is being unrealistic in this. I really come back and I ask that sentinel question. And when we have a dialogue there, it's like, we're missing the point, or we're missing the understanding or the resistance of what we're doing. And then, obviously, as you look at that, you need to make sure that you do have that background data that's going to be necessary to support the simplification and the discussion that you have there. Again, if you can kind of frame the issue or the hazard simply, you can think about it in the workflow and how it fits into the work process. And again, start with, what is the problem we're trying to solve? You will be much more successful, and I would say much more satisfied when you're dealing with these hazardous chemical challenges in your work.
Definitely check out Mike's episode if you have any interest in dealing with hazardous materials. Also, check out Lynn Kilpatrick, who also has a great episode on hazardous materials. I get asked sometimes what the job looks like to be a fire protection engineer. I think Cathleen Childers, who is a professional engineer in New York City, has a great response to this question. In this clip, there's a good back and forth between Kat and I on the process of fire protection engineering and a typical work week for Kat.
So, as we kind of were chatting about earlier, we're all working from home now, so it's definitely not what it used to look like. But I have always enjoyed, maybe we'll talk about my typical week, getting out of the office a little bit. So with the healthcare and some other stuff I've worked on, there's a lot of inspections that I have to do, which, if you're going 100% inspections, it's driving you crazy. But if you're in the office every single day for months, you're also going crazy. So yeah, I, in my 4 years at Cosentini, have gotten a good mix of inspection versus design. So we just wrapped up, we're kind of wrapping up a project where we were looking at fireproofing and fire stopping above the ceiling in a 1,000,000 square foot building. So that was a lot of months
Wow.
of being out in the field, you know, on a ladder with a flashlight. And that stuff is really interesting to me. And I think you need to have the full picture for that, right? So you're going up and you're looking at these things and you're noticing, you know, one tiny square inch of an issue. But then, you know, you have to remember the person that you're going to ultimately submit this report to, does he care or does he just need to know what needs to be fixed, right? So I think like the biggest thing is understanding the construction process as a whole of like, I'm looking at this so that I can create a document that tells somebody else how to fix it. Yeah, the inspections, the report writing, you know, I like when it's the full process and it makes sense to me, right? So, you know, that was fireproofing, but it could be sprinkler design if it's an existing building. You got to come in, you got to somehow be able to express to somebody what's there, what they can reuse, what they have to remove, and what needs to change going into it. And you know, a lot of times with the design, you know, people are worried about the AHJ approval and this and that, which is all, you have to look at everything, right? You don't just want to put things on a drawing so it gets approved. You want to put things on a drawing so that everybody who picks up that drawing understands what you saw and what you need it to look like at the end. So inspection, report writing, drawings, a lot of meetings when things don't go great or when they're going good. The collaboration on projects is so important, right? Like when you're designing the system and you're, you know, all just staring at your computer screen, trying to figure out this valve room, you got to talk to the architect, right? Like, hey, can you make this room a little bigger? Is this absolutely it, right? So, you know, you can spend hours trying to solve a problem that might not be a problem if you had just picked up the phone and asked the architect if there was anything that they could change. So that part is fun when you have a good team who's all on board. It's nice when you see the process work well.
Yeah, I think I said this before on the podcast, but you know, you get into fire protection and you think that fire protection is going to be the hardest thing you do, but turns out that coordination and teamwork and communication end up being the things that are the hardest, and you know, vary the most from project to project is the people in the team and the stakeholders. And I like what you said about, you know, knowing your audience with these projects. You know, every project's different, and you know, who you're reporting to or what the end goal of the project is always different. So you have to know your audience when you're writing these reports and, you know, making these engineering judgments, as well as knowing the technical for, you know, why they shouldn't have the conduit or the sprinkler pipe in the rated wall without, you know, protection.
Yeah, and you know, in healthcare and some of the government projects that I've had, I found that having a fire protection engineer on the owner or client side, you think it's going to make your life harder, but it often makes it so much easier to have somebody on the client side just say, yeah, that's absolutely correct. We absolutely need to make this change. You know, sometimes when you're the only person in the room saying, you know, you can't do that, and everyone's like, well, why? You know, it's nice to have another person who understands where you're coming from, especially when they're on the client side.
Definitely, and having somebody who knows what they're doing on the client side is going to help you get the information for you to get your design going and get everything moving along the way it needs to be in the first place. And, you know,
absolutely,
yeah. So if you need information about existing systems or, you know, what they really want for deliverables, then you have somebody who, you know, understands what's required, you know, talking to you about what they want instead of, you know, part of the consulting and just engineering and architecture stuff is in general is narrowing down these nebulous thoughts that the owner might have about what they want or what they need, and kind of synthesizing that and giving them something that is going to make them happy at the end of the day and achieves what they're trying to get at. So yeah, it's hard to do, and it definitely helps if you're talking to some people who know what's going on. If you're looking to hear some more commiserating of fire protection engineers, go check out episode 7 with Cat Childers. This next clip is Andy Lynch again talking about the listing process and really breaking down why we have to get fire and life safety products listed.
You know, the big three in North America and the U.S. is you've got Factory Mutual, you've got Underwriter Lab, and then you have Intertech. So you've got the FM Mark UL listing, and you've got the ETL, which is Intertech's mark there. So it really depends on if you have a product that already has a standard, or if a lot of the companies I work with have a very new and unique technology. So you kind of have to either find the standard that closest fits, or you have to talk to FM about creating a new standard, test standard. The reason we have these companies to start is that when we look at, the life safety industry, we want to make sure things work. We want to make sure that we're getting the same piece of equipment every time we purchase it, that changes aren't being made that could, change the functionality of it. And it's for consistency. So the testing portion of it, the fire performance test is just one piece of it. Most of these processes to get a listing is actually a lot of component testing. So they want to see what failure rates of certain rubbers and plastic gaskets are. They want to, make sure that the functionality of some valve or some circuit board, there's one test where it's just turning a device on and off 500 times. There's a lot of just wear and tear, corrosion, electric tests, that just to make sure that the device that's going out in the field is going to be resilient. So, and then you've got temperature tests where they bring stuff down to -40 or 0 and up to 100, 120, whatever the high temperature is. So a lot of it is component testing. You have the fire testing, and the next part is looking at the manuals, looking at your spec sheets, anything you're going to put FM on. They want to have control of that to make sure you're not saying something that's outside the listing. You're not making a claim that isn't true. And so it's protecting the market. It's protecting, it's a life safety device. So they want to make sure that that's going to function. And then with FM, there's follow-ups on the manufacturing facilities. They actually come out and do quarterly audits in some cases where every quarter an individual from FM comes into the facility and makes sure that your manufacturing process, your quality control in the manufacturing process is there. So when you get a product to submit it, go to FM, their website, they kind of break it down by different departments. And you'll send in drawings, you'll send in your manual, you'll send in, there's paperwork attached. I do an authorized agent form for my clients so that I can speak directly to FM on their behalf, and then they'll give back a quote. If there's a standard that already exists, the quote's pretty cookie cutter. They say this is how much it's going to cost, depending on what device. It can take up to a year. I know that with any kind of pressurized cylinder, they have a year-long leakage test. So you're going to start that right away, and then you'll start doing all the other component tests in the meantime. So a year is a typical time frame. It could be shorter if it's a simple spray head, open, deluge spray head. It could be, 3 months. Prices range from $3,000 to I've heard tests, for ESFR sprinklers, they're actually going to do full rack tests. So it's going to be very expensive to run those. I've heard tests as high as or close to $1 million to get a listing on some devices. If there isn't a standard, then it's a lot more difficult. Now you're talking about a 2, maybe even 3-year time frame where you're presenting the technology, you're presenting the case on it. Someone has to kind of be your champion at one of those organizations and say, yeah, we can see why this would be, benefit the industry. Or in FM's case, the reason FM's approving is for their insurance clients. So they want to make sure that there's a reason that their clients would be putting putting that device in. So if you do find that champion, then what they're going to do is say, okay, we'll form a committee and we'll write a test standard, and they'll usually give you a cost associated with that. When that cost, if you pay that cost and they move forward and they build that standard, then you pay to actually test to that standard. So you kind of hit double hard on that aspect if there isn't a standard already.
Wow, I couldn't believe after Andy said that it could take up to 3 years to get a product listed through FM or UL. Here's another great clip from Chris Campbell talking about how to conduct a life safety analysis for a building.
Yeah, we do, and that's a good question, Gus. It does vary from project to project. I think in my mind, the ideal case is that when we're working with an architect, that we are brought in at the beginning of the design, ideally in just the concepts phase, where it's just the general concept of the building, and we don't even have full scale plans yet. It's maybe just renderings or some blocking and stacking diagrams or something like that. And when we're able to get in early on, we can offer a lot of guidance about what is the, for example, the type of construction that you could choose based on the size of the building that's being considered and the occupancies that might be in the building. And that really then feeds into the allowable height and area and requirements for fire protection of structural elements. So you get a lot of the basics early on covered if you're able to get in early on the design. So we prefer when that's the case. I will say there's a lot of times where architects don't bring us in that early, and we're almost brought in after the fact. And if the architect has done a really thorough code analysis, sometimes that can work out just fine, and we're just making some minor tweaks. We've also had instances though where we're brought in kind of later, and there's some pretty major concerns that we have about the design. So we do typically start with what is the construction type of the building, and then that goes hand in hand with how big is the building in terms of height, number of stories, and area. Another big item is just identifying any of the IBC Chapter 4 requirements, which are the detailed requirements based on use and occupancy. So a few major ones in that would be, if the building's a high rise, there's a series of life safety and fire protection requirements that are triggered for that. We do also do a good bit of residential work, so there's a number of Group R specific requirements, both in Chapter 4 and then also in Chapter 10. So that's usually the starting point. Once we get further on into the design, so into schematic design or design development phases, then we're typically doing a more detailed egress analysis where we're taking a look at the architect's life safety plans and their occupant load calculations, verifying them, making sure that the egress system is of sufficient capacity to handle the occupant load, and also that it's set up correctly in terms of where the exits are located, exit remoteness, travel distance, common path of travel, things like that. And then finally, a big portion of our role in life safety is assisting the design team in obtaining a building permit. So once a permit submission is made for almost every project, there's usually several rounds of permit review comments that the local building and fire departments make. And we play a big role in looking at those comments, evaluating whether we agree with them or not, and then assisting the architect to make any necessary design changes to address those comments, or perhaps negotiating with the code officials to try to argue for our point of view and why we think the design that we have is correct.
This next clips block is about fire investigations. This first clip from Richard Meier discusses some of the fundamental topics of fire investigations, such as fire patterns, fire effects, and origin and cause investigations.
Okay, well, I can't talk about fire patterns without first talking about fire effects. And a fire effect is the effect that the fire has on a particular material. It may be melting, it may be charring, it may be loss of mass, it may be change in color, it may be change in chemistry. An example of change in chemistry is gypsum wallboard. Gypsum will go through a process called calcination, and what it is the heat drives the water out of the gypsum. So you have chemically bound water, and then you also have free-floating water that's in this mixture. The heat drives it out, and it turns a solid, hard material that normally you'd have to punch pretty hard to put a put a hole in it into the soft chalky stuff that crumbles when you poke it with a finger. So if we look at that just as an example, so that's a fire effect. Now, if we look at it on a wall and we see that it starts in the lower left-hand corner of the room and extends upward into the upper right-hand corner of the room, well, that's a fire pattern. And the patterns can be, a large effect or collection of effects. Actually, fire patterns can actually be very small too. I've had cases where we're looking at, say, a gas leak out of a butane lighter. And in that case, you're looking at fire patterns that might only be a couple of millimeters. But generally speaking, when we're talking about fire patterns and say residential fire, we're talking fairly large patterns. Could be a couple of feet, could be size of the room, whatever. But we look at those patterns, and there have been a lot of things attributed to fire patterns over the years as this shape means this and this shape means that. And some of that is true, some of that's not so true. But say if you have a what we call the classic V pattern, you have a pattern that starts small at floor level and goes upward. Well, we can infer from that hey, there's a fire that started there, that the fire plume went upward. Once it hit the ceiling, basically it hits resistance, so it starts going sideways, and that's why your plume goes from basically an inverted V or a straight up and down pattern to going wider at the top. So we can say, okay, a fire started here or was burning here. Now, the more important thing I think about fire patterns is they can tell you time and or intensity and also direction. And that's the goal of fire patterns really is to find the origin of the fire. Where did the fire start? So if we look at each pattern and we say, okay, this burned either burned very hot or burned for a long time, and also it can point us in a direction. Well, we know which way the smoke went, or the fire plume went. So if we go the other direction, well, the fire pattern's in that way. And if we take more than one of those, we take two or more fire patterns, we're starting to do what we call heat and flame vector analysis. So we take all those fire patterns, and it will, going back from whence they came, that will point us to the area of origin. And the area of origin is important because if we can't determine the area of origin, we're going to have a hard time determining how the fire started. Once we get that origin down to as small an area as possible, we can start looking for the potential sources of ignition and the potential first fuels and additional fuel packages that added into the fire.
The discussion of fire effects and fire patterns is fascinating. My grandpa was a firefighter, and he would talk to me about these very things when I was a little kid. Check out this clip from episode 4 with Aaron Johnson, where he discusses a nuisance foam discharge and the ensuing investigation.
Yeah. So, fire investigations, like I said, I've done several of those, but I'm always more intrigued almost by the system activation, because they're not supposed to activate unless there's a fire, right? So it's like you have the system that's meant to do something it doesn't do. So I guess that's why I'm intrigued by, why did it do this thing that it's not supposed to do, that everybody kind of worries about it doing. But they're interesting to, first of all, find out, go to scene, hey, find out what happened. Here's what happened. And then it's interesting to kind of play it backwards. Say, all right, well, for the system to have dumped its contents, what would have had to happen for that to take place? And then you realize, oh, okay, you trace it back. It could have been maybe it was a solenoid. Maybe first you have to rule out all the things that it wasn't. Well, there's no one in the hangar at the time, so nobody pulled the pull station accidentally. Isn't not saying that they did. So no one pulled the pull station. There was no fire for sure, right? You look around for evidence of that, so you can rule those two things out. Maybe it was the weather. I know we've had a couple where a lightning strike actually set off maybe some alarm systems or things like that. We actually had one hangar I investigated. The system had dumped, and it turned out that it was in the middle of a bad tropical storm force wind type of storm. And what had actually happened is the foam release pull station had gotten water down inside the back of it, and it had shorted out and caused the solenoid to open, which caused the system to dump. So that was an interesting one. But just stuff like that, looking for that. what is that thing? Because you see things that every investigation is different, and every time you do one, you realize something else that could have happened. You might have done 10 investigations, and that 11th one is something completely different than all the other 10. So that's always neat. And I'm really involved in the codes and standards side of the thing. I sit on several committees, and I like doing that work. I always tell people that's the most important part of the job, is even more than the enforcement, is being in that process where you write and develop these. So looking to see, getting into these investigations, find out, hey, here's what's happening. That really can inform a lot of that code development process. I know that for 409 and FPA 409, the stand for aircraft hangars, they're in a revision cycle right now. And the big conversation was about, the insurance companies are saying, hey, we're not seeing any hangar fires, but we're seeing a lot of these foam dumps that are costing us lots of money. So what can we do to change that or address this issue? And so a lot of changes are coming out to actually address that, to say, hey, maybe we don't need foam in as many hangars as we think we do, or as the code currently requires. So what can we do to not, without creating a greater risk, what can we do to still mitigate the risk, but maybe also cut down those costs on those activations and that foam damage?
We'll get into more of the codes and standards process later, but in the meantime, check out this clip from Bill Gustin about the change in construction types between legacy and modern construction and the effects that has on fire in the built environment.
Fire is a gaseous phenomenon. It has to be, the fuels have to be vaporized in order to burn. And I've experienced this. If you don't think fire is a gaseous phenomenon, just take a look and see what happened in Los Angeles over the weekend. It's a gaseous phenomenon. And solids have to thermally decompose, pyrolyze. And in our petrochemical environment today, see, I'm an old bull here. Now, I was a firefighter in the early 70s, early 70s, and we didn't even wear a breathing apparatus. We could put out a room and contents fire without a breathing apparatus, without a hood, a Nomex hood or a PBI hood, with Gardner gloves, with a 65-gallon-a-minute nozzle with an 1.5-inch hose line. Why? Because back then, just about everything in a household was a naturally occurring material. Wool, wood, cotton. But today, just think in your lifetime. I don't know how old you are, Gus, but I know I'm older than you. I'm probably the oldest guy in the room right now. But even in your lifetime, Gus, think of how many things that used to be made out of metal are now made out of plastic. The whole environment has changed. When you take a look at that Underwriters Laboratory side-by-side comparison of the legacy, like the 1960s, 70s living room, versus the modern furnishings of today, which are basically polyester, polyvinyl chloride, polyurethane foam, where the time for flashover years ago with naturally occurring materials was like 24 minutes. Today, less than 3 or 4 minutes. The whole thing has changed. It used to be that you could have a small volunteer fire department, have a fire in your house, and let's say it takes them 20 minutes to get there at best. The fire is still basically in the incipient phase. Today, no. It's post-flashover, and in many cases, because of the building being closed up, it's ventilation limited, oxygen deprived. In other words, the fire reached a crescendo, but then it ate up the available oxygen, because petrochemical-based material, in order for it to be converted into energy, has to unite with oxygen. Well, the amount of oxygen released, or the energy released, has to be dependent upon, do you have enough oxygen? Well, very quickly, fires in today's structures, which have never been tighter in terms of energy efficiency, weather tinting or weather stripping and thermal pane windows, the fire reaches a ventilation limited or an oxygen deprived state very quickly, to the point where there might not be anything showing in terms of smoke pushing out of that building. Because why? because the fire is diminished in intensity. And when it diminished in intensity, it diminished in temperature. And what's forcing the smoke out of a building is the pressure differential based upon the temperature. So it is not uncommon today for fire apparatus to pull up on any type of structure and have nothing showing. But on closer examination, you got a dragon sleeping inside that building, just waiting for a good gulp of oxygen.
Our next segment is about codes and standards development and the importance of being involved in the process and promoting the process in general. I hope you enjoyed these next couple clips because I sure have learned a lot about codes and standards development since I started Fire Code Tech. In this first clip, Aaron Johnson talks about what he's learned from being involved in the codes and standards process and the value it brings to you professionally.
Yeah, so I mean, like I said, I preach it to my people at my department, and pretty much any time someone will listen, that it's really the most important thing that you can do for the industry, and it's also not in a selfish way, but also for your career as a whole. I mean, it's good for the industry because you're contributing to it. You're actually, if you're on the ground, you're seeing what goes on from whatever perspective, whether you're an engineer, a designer, a firefighter, or an inspector, you're seeing a different perspective of how this code's applied. And being on those committees and being able to, or not even if you're not on the committee, you can still provide input. So providing those inputs and taking part in that process, it goes a long way and it makes a big difference. And it's very important. And it's great for your professional development, I guess I should say, rather than for your career, but for your professional development as well. You go to these meetings and you're with, some of the people they've been doing this for a long time, and there's a wealth of knowledge on these committees. It's like they pull all the knowledge on this subject is all sitting in this one room. And so you get to it's a great learning experience as well to learn from and talk to these people. But yeah, I mean, so with the NFPA and the ICC, they have kind of a different process, and I'm a little bit more involved with the NFPA side. They have more committees and more codes and standards and things like that that require committee work. So I'm on several committees, but I'm primarily involved with the Aircraft Facilities Committee, which is 409, 415, and 423, and also the ARF Operations committees as well, which that includes things like NFPA 402 and all the operational sides of the aircraft rescue industry, all the codes that apply to that.
It was really interesting talking to Aaron about his work on the codes and standards development process. His knowledge as an aircraft rescue firefighter and as someone who is involved in many of the 400 series aircraft-related NFPAs is fascinating. This last clip about codes and standards is Chase Browning and I discussing how people benefit from the standards and codes getting more detailed each code revision cycle. Take a listen.
One of the upsides to the codes and standards getting, thicker and bigger every 3 or 4 years whenever they come out is a lot of the interpretive stuff gets addressed through the standards and codes development process. I remember years ago, there was, when like NFPA 13, the installation standard for fire sprinklers was half the size it is now, or even less. And, people, opinions vary about whether that's a good thing or a bad thing, that the codes and standards now address tons of stuff that they don't have to. Some will say, and others will say, hey, these standards, now finally address these gaps that lived in these codes for years, where they would, cover basic stuff, and there would be invariably pieces that the codes wouldn't address. And then, of course, it comes out during the design, or during the bidding, and into design and into the installation phase of these fire protection systems, that these codes don't address X, Y, and Z. So let's fix it in the codes, and then you get a new chapter or you get a new section that has, that address whatever gap that was there. So I'm always encouraged by the people being involved in the code development process, because it's, it hopefully is a vehicle to deal with the concerns that show up when there's just something missing from the codes and standards.
I think it's a good thing that they keep getting denser and keep explaining more about, the process. There's so many different situations that you could run into with the building, just an infinite amount of ways that you could construct the same wet pipe sprinkler system. And so I think that more information is usually a good thing. That does raise the barrier to entry for those not as well versed in the code books, but I think it's a good thing. The last segment of this Clips episode for 2020 highlights is going to be about trending topics in the industry. I like to keep abreast of the knowledge that is currently being promulgated and studied in fire and life safety. Here are a couple clips of some topics that I saw trending in 2020. This first clip in the segment is Aaron Johnson talking about fluorine-free foams in the hangar fire protection industry and how that people are working around trying to use these more environmentally friendly and less hazardous materials.
No, I mean, kind of on the tail of what you were just saying. I mean, that's the biggest thing right now. The biggest change or the trending topic is the PFAS and PFOA free foams, and making sure they're not carcinogenic and they're safe for people and the environment. So that's the big thing kind of in the industry. And, if you think about the reason that we require foam in hangars anyways is for the risk or hazard of large fuel spills and large fuel fires. And, the industry at large isn't really seeing a huge number of those. And, and sometimes your hangar size can only house a certain size of an aircraft anyway, no matter what. And, you're not going to have that risk of a large fuel spill, and a fuel spill ignition isn't going to be as great. So I think those are the changes we're seeing and happening. So I think it's a combination of both of those, a lack of seeing the large fuel spill fires and also wanting to go to that, the carcinogenic free and environmentally friendly type of product as well.
The last clip in this episode is going to be Mike Snyder discussing the tragedy in Beirut with the ammonium nitrate explosion.
Oh, absolutely. So, let's preface this by the fact that there's a lot of details that still have to come forth. And while I think there are some things that are very obvious as we look at this, I am sure some of the details may change the view exactly of the scenario and how it played out. But and I'm going to call it frustrating part about this is ammonium nitrate has been involved in large loss incidents for more than 100 years. And the basic premise and causal factors that are involved have not changed, right? So basically, ammonium nitrate is classified as an oxidizer, which means when exposed to fire, it will accentuate the fire by essentially giving it more, and I'm using in quotation marks, oxygen, but more oxidant so that you can enhance combustion. So ammonium nitrate normally as a solid, which is oftentimes in prills or flakes as it's stored, is all by itself is fairly stable and you don't worry about it. It is when you expose it to heat or contamination and store it in large quantities, piles that are put together, and a fire occurs, the results are cataclysmic, right? It's the outcome is literally predictable, right? And a person that I mentor with, a gentleman by the name of Gordon Graham, always says, if it's predictable, it's preventable, right? You can put controls in place. And so all of the things that we need to be working on are how do you isolate the material so contamination cannot occur? And if there's going to be a fire, ammonium nitrate is generally not going to be the start of the fire. It will be some other combustible commodity. How do we end up putting that fire out or controlling or preventing the fire from occurring? It appears in Beirut that this warehouse where the ammonium nitrate was also had other commodities, particularly fireworks and probably some other combustible commodities. And so the fire likely started by an area that, something that was not ammonium nitrate. But then once the fire got going, and you look at these historical events that have occurred, usually within 30 minutes to 90 minutes, with the fire that continues to burn, you get a ferocious fire because of the presence of an oxidizer, and you progress to detonation. And these detonations are horrific. In the U.S., our most horrific ammonium nitrate detonation was back in 1947 in Texas City. and that was a ship that had ammonium nitrate fertilizer that caught fire in the Texas City ship channel. And I think like about 580 people were killed, including the entire Texas City Fire Department. So these types of outcomes are predictable. And so, obviously there's a focus on our building and fire code in how we manage those, right? And how we control the hazard, and in making sure from an emergency response standpoint, we address these hazards and know that, generally speaking, if fires get into these stores, it's something that we have to isolate and evacuate quickly. This brings back memories, for example, of blevies in liquefied petroleum gas. Right in the 1970s, the fire service went through a large epiphany about fires exposing propane tanks are ones that if you can't immediately get water on, you have to evacuate. Else there's going to be a blevy and people are going to be killed. And property is going to be damaged. I'll just say one other quick thing here, and we can explore a bit further if you'd like. In the U.S., we recently, and I mean in 2013, in West Texas, at an agricultural supply house, we ended up having a fire, and in about 30 minutes, a detonation that killed, I believe, 15 people. And the U.S. Chemical Safety Board has done a comprehensive investigation that you can go to the Chemical Safety Board website and bring that investigation down and look at it for free. I would encourage you to read that. The frustrating part about that is there were two items in that investigation that were highlighted. And one was what appears to be an oversight in the U.S. process safety management regulation was to not include ammonium nitrate as one of the chemicals covered by the standard. That has not yet been resolved. And then the other one is that OSHA 1910-109, which is titled explosives and blasting agents, right? So people kind of immediately go, well, I'm using ammonium nitrate. I'm not an explosive or a blasting agent, but that has application for the storage of ammonium nitrate. Paragraph I of that standard has requirements. And so, I don't think necessarily that there's going to be a lot of new requirements. The science is pretty battle tested. I think it's our application of this science and our awareness of the hazard that has to change.
Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.